Hello and welcome to a brief review for Anatomy and Physiology 2, Test 1. Now the goal of this review is to walk you through the things that I find of particular importance for your exam. By no stretch of the imagination should you only study the things I discuss here. Everything's fair game, things that you've seen in your quizzes, most certainly things from videos and PowerPoints. My goal with this is simply to point you in the right direction, getting you looking where you need to look in order to be successful. Alright, so with that in mind, let's get to work on this and see where it takes us. Now, I will do this in order of the chapters that are involved here. So that would be blood, followed by heart, followed by blood vessels, and I may mix some things up from time to time. I really just kind of go through these materials and find what I would prefer to discuss, and that's where I would like you to focus. So, with that in mind, let's proceed. First and foremost, blood. You need to know about general blood chemistry. So what are the general characteristics of blood? What does blood look like? What is it? What does it entail in terms of the general characteristics therein? Tell me about the functions of blood and sort of what blood is for. Tell me about what it transports and how it transports different materials. Tell me about blood as a whole. So what is involved in whole blood? If you take blood and spin it down, what does it look like? What are the different parts that are found there? Tell me about plasma. Tell me about the buffy coat. Tell me about the hematocrit. Alright? Be able to walk me through these concepts. Tell me about, let's see here, in the plasma, tell me about plasma proteins. Alright? Who are involved in where? So what are globulins? What's albumin? Tell me about gamma globulins in particular. Like explain these concepts to me. In there also, walk me through the concept of platelets. Okay, what are platelets? What are they for? What do we have fiber in our blood for? So what's fibrin? What's thrombin? Tell me what these are and how they behave together to lead to blood clotting. So I want to know all about it. Tell me about how blood forms. So tell me about bone marrow. Tell me about hemocytoblasts. Tell me about megakaryocytes and sort of what they lead to. And in particular, I would like to know all about how you regulate your red blood cells. Okay? So tell me about the hormone that's used to increase the speed at which red blood cells develop and where it comes from. Tell me about the general details of red blood cells and what they look like. Tell me about the lifespan that red blood cells have. How long do they live? Tell me about what's unique about them and their lack of nuclei as an example. Tell me all about hemoglobin. What is hemoglobin? What do I mean by heme? What do I mean by globin? When you break down hemoglobin, what happens to the different parts that are there? All of these things really matter. Let's see what else we have here. So, take me from formation of red blood cells to their death. Tell me where they are cleaned in the blood in particular, as in where they are removed, what organ you might say. Tell me about the different types of anemias that you might see and what they might mean for us. Again, remember that anemia, like the different formats here, they are not a disease of themselves. They are normally a sign of another problem. So what problems might lead to different forms of anemia? These are things that you're going to see in your future, so now's the time to realize it. Alright, tell me about white blood cells. And this is pretty straightforward stuff. Tell me which ones are more numerous, which ones are less numerous. Tell me which white blood cells are large, which ones are smaller. Tell me their functions, okay? Which ones are really talented at attacking bacteria. Which ones are really talented at attacking like bloodborne parasites or worms, you might say, within our system. We have all these different white blood cells to accomplish different tasks, and I want to know what they are for. Which ones are granulocytes? Which ones are agranulocytes? Just walk me through it and explain it to me a little bit. And that is the blood. All right, moving on to the heart. So in the heart, man, I want to know all about cardiac muscle. Okay, tell me all about cardiac muscle. Tell me about the mitochondria. Tell me about how it's structurally formed. Tell me about the unique barriers, the unique junctions between cells. Tell me about the gap junctions. Tell me about how the cells undulate to increase their area. I want to know all about heart muscle. All right, tell me about that cardiac muscle in detail. Be able to tell me about the layers of the heart. All right, tell me about the inner lining of the heart, the middle portions, the outer portions. Like, I want to know all about it. Like, explain the serosa to me. What do I mean when I say the heart's found within a sac in your chest cavity? What is a parietal pericardium? What's a visceral pericardium? I want to know all about it. And I'm going to jump around here a little bit. This is the way that my notes are organized. What are some medical conditions that involve the heart? Like, what's a pulmonary embolism? Okay, what is an embolus? What's a thrombus? What is pericarditis? What's a heart murmur? Like, tell me about these situations and what might happen. When would you get these, as an example? Tell me about the problems therein. When might you have to have bypass surgery? What's a stent? Angioplasty. Walk me through the concepts, all right? Now, the heart itself, you obviously need to be able to tell me left and right ventricles and why they are of different size. I'm here to tell you that you need to be able to walk me through the pulmonary circuit and the systemic circuit in detail. Tell me which valves are where. Tell me where blood's oxygenated and where blood is not oxygenated. Tell me where blood goes and how it gets back. Walk me through that pulmonary and systemic circuit. All right, within the heart itself, tell me about the pacemaking system that's there. Tell me about the sinoatrial node, the atrioventricular node, bundle branches, etc., all the way down to Purkinje fibers. I want to know all about the heart and its pacemaking system and its general conduction system. Okay, you better be able to walk me through how the heart sends messages. Tell me about how you feed the heart muscle itself. Where do the blood vessels come from that feed the heart itself? All right, again, the blood pumped by the heart is not what's feeding the heart muscle itself. Tell me about those blood vessels coming straight off the aorta there and where they go. All right, where they go. What is cardiac output? What is stroke volume? Tell me about the heart sounds and what they actually are. Like what sounds are heard there. Walk me through an ECG. All right. What's a QRS complex? What's a T wave? Like, you got to be able to tell me all about these ECGs. And if I give you an issue based off of an ECG, probably not a terrible idea to be able to explain it to me. All right. And then last but not least, let's talk about some blood vessels. Oh my gosh, there's so much here. Tell me about arteries and the various tunics that make up the arteries. Take me to the arterioles. Tell me about what's special about the arterioles and how they function in regulation of blood pressure. Tell me about the capillaries, like all the different types of capillaries. I want to know about fenestrated capillaries, sinusoidal capillaries, continuous capillaries. Where would you find these? Why do you have them? Why do they matter? Capillaries are very, very important for you. From there, take me to the venules, take me to the veins. Tell me about how your veins hold massive quantities of blood and why. Explain to me how venous return works. How does blood get back to the heart from the venous side if the pressure's low? Tell me about why the veins often will have valves. Where might you find valves within the veins? Like, all of this matters. Okay, all of this matters. Okay, let's see what else I've got for you. Tell me about arterial pressure. Okay, arterial pressure versus capillary pressure. Like, what do I mean when I say resistance, and where is the resistance going to be in that grouping? In terms of arterial pressure, where would you expect to find more arterial pressure versus less arterial pressure? So what arteries are going to be under... in essence, I'm asking you about the different types of arteries here, folks. So tell me about the different types of arteries and where, like, which ones are kind of set up for taking the pressure and which ones are not. Tell me about how you get continuous flow from the heart as opposed to individual surges of blood with the pumping of the heart. Like, I want to know about it, folks. You got to explain it. That's sort of a pressure question, you might say. Speaking of pressure, tell me about baroreceptors. All right, where are your baroreceptors? What do they measure? And what's their use? Why do they exist? Explain baroreceptors and the reflex arcs therein. All right, you should obviously be able to explain to me variations in blood pressure. What is a systolic pressure? What's diastolic pressure? what's happening during each of those. What is normal blood pressure? Okay, give me numbers. What's normal blood pressure in millimeters of mercury? What would low blood pressure be? What would high blood pressure be? And what might those numbers tell you? All right, somebody's got high blood pressure, somebody's got low blood. Why does it matter? And be able to explain it to me. And then changing gears here a little bit. Again, I'm going to jump around a little here. So walk me through basic blood typing. Most of you folks are going into some sort of medical field. You need to be able to tell me about blood pressure. You need to be able to tell me about blood typing. Okay? What are antigens? What are antibodies? Who can receive what blood? Who can donate to whoever? All right? Be able to walk me through the general ideas of blood typing and who can get what. And again, what do I mean by antigens, own red blood cells themselves? What do I mean by antibodies? And tell me what can happen, like what's a transfusion reaction? What could happen if you give someone the wrong stuff? And sort of built on that concept. So we had discussed rhesus positive versus rhesus negative blood. And I believe we talked about the hemolytic disease of newborns. The drug Rogam as an example of this. So what is Rogam? What is hemolytic disease? Why does it matter? This is so important from a medical perspective. So yeah, to be able to tell me about these blood transfusion issues that can pop up. And I believe that is about the extent of what I've got to say. I will say this one more time, however. If I were you, I'd be friends with the pulmonary circuit and the systemic circuit and be able to kind of walk me through the path of blood in the system. All right? And that is a nice review. All right, a nice review of the basic concepts here on Test 1. And again, this is not exhaustive, but it's a huge help in aiming you in the right direction. With this, with the quizzes that I've uploaded, you should be in pretty good hands. So have a nice day. I hope you do extraordinarily well. Study, study, study. Thanks.